Hey friends, this is Abinash and today we'll be solving a very interesting question. So the question is convert sorted linked list into a binary search tree. Okay, so let's read out the problem statement. So basically in this question we are having the head of the linked list where the elements are already sorted in ascending order. Okay, so we need to convert it to a height balanced BST. Okay, what is height balanced BST? Okay, so it's a very important concept that you need to understand before actually moving to the solution itself. So let's say that we have a linked list. Okay, we have a single linked list like this. So as it is already sorted in ascending order, so whatever element I would choose to make it the root of the BST. Let's say that I choose 5 to be the root of the BST. Okay. So what will be its left element? Its left will be filled recursively by this particular list, and its right subtree will filled recursively by this particular sublist. Okay, so the left will be obviously the maximum element of this particular sublist. Okay, the maximum element is 0, right? Why maximum? Let me tell you, because in VHT there is a property that the root node, the root's value must be greater than or equal to whatever the maximum value in its left subtree. Okay, and okay, I'm sorry, maximum, and its right should be lesser than or equal to, I mean the root's value should be lesser than or equal to its whatever minimum value in its right subtree. Okay, so by following this particular property we will try to create a BHT, okay, to understand the height balance property for any tree. Okay, so so basically the left element will be 0, right? The left subtree's root element will be 0 in this case, and its left will be filled recursively by this particular sublist where the elements are -10 and -3. So the maximum is 3, so obviously it will be 3. Okay, and its left will be -10. Getting? Perfect. So okay, so as this is not violating the property of the binary search tree, so we'll move on, and its right will obviously be filled recursively with 9. Okay, so this is the binary search tree that we can build, right? So this is one of the binary search tree that we can make. But if we want to create the binary search tree by taking 9 as the root node, then this is okay. If I want to take 0 as the root node, then also fine, right? Any element I can take as the root node, right? So accordingly the structure will be changed. Okay, so now let's look into this particular binary search tree for this particular time to understand the property of the height balanced binary search tree. Okay, so what is height balanced tree? Let me tell you. Let us say there is a root node for any such tree. In this case, it is a binary search tree, but for any such tree, right? Let's say this is a root node, and it has some, it has a left subtree and a right subtree. Okay, so let's say the height of the left subtree is LH. Okay, and height of the right subtree is RH. Okay, so if I would find out the absolute difference between these two entities, that means LH and RH, okay, um, okay, and if this is lesser than or equal to 1, then I will call a subtree a height balanced subtree. So let us say this is a tree, or it is a subtree of any it is a subtree of the given tree. So if this property is satisfied for any such subtree, then obviously it's a height balanced subtree. Okay, and a height balanced tree will be a tree in which every subtree follows, every subtree should satisfy this particular condition, right? Even the root as well, right? So I hope you got the point. So now let's look into the example that we have taken. So basically this is the binary search tree in which the height of the, I'm sorry, the height of the left subtree is 3. Okay, there are total 3 elements, you can imagine. Okay, and the height of the right subtree is 1. Okay, this is 3 and this is 1. And if you find out the absolute difference between left and right, it will be 2. It is more than 1, right? So this is why it cannot be the it cannot be the height balanced. Let's say we will add some more nodes to the left of this particular list, then the left will gradually grow, right? And the difference will increase between left and right. So this is violating the property for the height balanced tree. So now let's now create a BHT by taking 0 as the root node. So if I'll take this, so its left will be -3, right? And its left will be -10, okay? And zero's right will be obviously, let's say 5 in this case, and then 9. Okay, so this is one case. The other case would be like this. It's -3 and it's -10, right? And it would be 9 and its left would be 5. It is also valid, isn't it? So both the trees, both the BHT are actually following the height balance property. Why? Because let's say uh, -3. Okay, let's take this particular node. So this particular node does not have any uh, right children. So obviously, difference between left and right will be lesser than or equal to 1. So it's satisfying the condition. Similarly, if I take 0, so the left is containing 2 elements and the right is containing 2 elements as well. So that means I'm in the height. Basically, I'm talking about the height. So the height is basically 2 and the right has height 2. So this is why the difference between these two are 0. So it is lesser than or equal to 1. It is also satisfying. Okay, these two are satisfying. And if I would say that 9 is also having a left children but not having a right children, so it is also satisfying. But I have not talked about the leaf elements, right? Why? Because leaf nodes are already height balanced. Why? Because it does not have any left and right, right? So this is because the height of left and height of right are 0, right? So it's already satisfying the height balance property. So this tree and this tree are satisfying the property. So if I'll move to its left, it will again fail. Why? Because there are total 3 in the right, but only 1 in the left. So this kind of structure will be mirrored, right? So I hope you got the logic that what is the height balance tree. So actually, I have explained the actual logic, the original logic to solve this particular question as well to you. But let me repeat if you still not have got the idea. So basically, guys, what we will do right here is we have to make is we have to build a height balanced BST out of this given sorted linked list. So what we have to do right here is we have to always take the middle element as the root of any such subtree. Okay. For example, why am I saying this? This to make the PhD in this way, because whenever we as we have already looked in the example as well, whenever we took any node as the root of the BHT, so obviously it failed. Why? Because the the total number of elements in the left is greater than total number of elements in the right for any such root node, right? But when we take the middle element as the root node, so obviously the left and right element, I mean the difference of left and right would definitely be lesser than or equal to 1. Okay, so at max the difference would be 1. Okay, but in the best time the difference would be 0, right? So okay, so now let's go with it. So basically when we create a BHT by taking the root as the middle of this particular linked list, and recursively for any such subtree we will do that only, then we can create a binary search tree which is also satisfying the property of height balanced. So I hope you understand the concept. So now let's code it out quickly. Then you can just tally, you can just map the idea of what you have understood in this code. Okay, so now let's handle some very quick base condition. So that is, let us say the head is null. So in this case we will return the null. Okay, because we do not have to create a BST with when the head is already null. So now let's say that we have a function which will get us the BST out of this single linked list. So we'll pass the head. Okay. Okay. Let's create the function which will get us the link the tree. Okay. So the return type will be tree node. Okay, because it requires a tree node to be returned, and we have the single linked list. I mean the list node type as input. So let's say the function is get BST as we have already defined it. Okay, and the head will be passed right here. So list node, okay, the head. Perfect. So right now let's handle a very quick base condition, the same one, right? When because this will be a recursive function, so when any point of time I just have found that the head is empty, I mean head is null, so in that case I have to return null, right? Okay, so as we have discussed earlier that we have to find out the middle of the linked list. Okay, whichever segment I'm currently looking at, I'm currently dealing with. So we have to find out the middle element for that particular segment. So the segment's middle element, let's say we have a function to find out the get mid, and we have passed the head of the linked list of that particular segment. So yeah, so let's find out the middle of the linked list. Then what we will do is we will create a the root, and the root will be of, okay, the root will be of the middle element. So for example, let's say this is the linked list that we have. Okay, the middle element is 0, right? So 0 will be the root of the BST, right? So what we will do is I will create a tree node with the value of mid's value, right? And what we will do is as the as this is the mid element, so we will fill its left, I mean we have created a tree node with the value of the middle element, and its left subtree will be filled by this particular sublist, and right subtree will be filled by this particular sublist. Okay, but there is a problem, let me tell you. uh, so basically the problem is that it's a linked list. Okay, it's a linked list. So let me just draw it quickly. Yeah. So it's a linked list. So basically what happens is whenever I just pick this particular node as the, as the tree node, then I want to create, I want to recursively fill the left subtree by this particular subtree, this particular sublist, I'm sorry. Then when I'm talking about this particular sublist, there is a pointer which is pointing from 3 to 0, right? It has to be unset, right? It has to be broken. Okay, then only I can say that this particular subtree, this particular sublist, I'm sorry. So basically what I'm talking about is this particular sublist should not have the middle element itself, right? So its next should be 0. So whenever I whenever I find the middle element, its previous elements next should be null. Okay, set to null. So we will make sure in the get mid function regarding that. Okay, all right. So what we will do is its left will be filled recursively with get BST, where the where we'll pass the head, and the head will be till -10 to -3. Okay, it will not consider 0 as the next for -3, right? So we will handle these things in get mid function, and roots right will be recursively filled by middle next, right? Because middle next is -5, and this sublist is basically starting from middles next. Okay, I hope you are getting me. Okay, get DST and mids next. Perfect. So in this case, we have, recursively build the left and right subtree for any such subtrees. Okay, so it's time to return our root. Okay, because it's ready. All right, so it's time for us to write the get mid function. So the get mid function will be list node type, because we are here to find out the middle of the linked list. Okay, and we need to return the middle. So as we need to modify the original linked list, why how we are assuming to modify, because we have a linked list and we need to find out a middle element, and its previous next should be set to null, right? So whenever we return the middle of the linked list, so the entire linked list is changed now, right? Because this particular let me pick my pen. Okay, this particular part is broken right now. Okay, only this much part is available, this much part is broken, but we have the head of the linked list, right? So there is no problem to access further. So I hope it is pretty much clear to you. I'm not making it so much difficult for you, I hope. Okay, so perfect. So in this case, guys, what we will do is we will just declare some pointers to find out the middle element. One of the pointers is like slow. So the slow is basically pointing to head, and the fast is basically pointing to head as well. So I'll tell you what actually slow and fast are doing. And there is another pointer that I want to have is the previous. So the previous is the significance of previous is that it will follow the middle element, right? So wherever the middle element found, the previous should be previous should be found just before the middle element. So the previous element initially is 0, previous node, and then what we will do is, let me tell you how to find out the middle element for any such linked list. Okay, guys, so let me clear all these things, right? So let's say that we have this particular linked list and we are very much interested in finding out the middle of this particular linked list. So how can we do that, right? Basically, we will declare, we have already declared two pointers. These are slow and fast. So let's, replace slow by S and fast by F. And so basically, as you can see in the naming convention, slow and fast. Definitely slow may be moving with one step and fast may be moving with two steps at a time, right? So yeah, so what we'll do is the slow will be moving one step at a time. Slow, initially slow was right here, so slow will be right here in the second round, right? And the fast will be jump to two step, one step to 3 and other step to 0, right? So this will be the position of fast and this will be the position of slow. So now the slow, let me erase it because slow was right here initially. So the slow will move to here, right? So this will be the position of slow, and the fast will be, okay, moved to uh, here to here, right? I mean two step at a time, remember? Okay, so fast will be right here. So right now it will stop. We will stop. Why? Because when we notice that fast's next is null or fast is null in any such condition. So the condition is when fast is null. Excuse my handwriting. Uh, okay. In any two condition, we will stop and we will declare that slow is the middle element, right? Okay, I hope you have understood the concept of finding out the slow. And similarly, if we will just declare another pointer that is previous, okay, which was initially pointing to the null, and let's let it follow the slope, right? So slope, it will be a slope will be assigned to it, and then slope will move ahead. So let in this way, the previous will be pointing to the immediate previous element of slope, right? So slow is the middle element, so the previous will be the immediate uh, node which is before it. So I hope you understood the logic behind finding out the middle element for any such linked list. So what we will do is we will see if fast is existing and fast next is also existing. In this case, low will move one time, one step at a time, and the fast will move two step at a time, right? Perfect. But we just have forgotten one thing, to assign the previous slope. So the previous will follow the slope, right? Perfect. So whenever the condition breaks, so that means we are right uh, at the middle element, right? The slope will be right at the middle element. But our job is to fix this particular issue where the previous next should be null, right? So we will see if the previous is existing, we will set its next to null. Okay, done. And as we have the slow as the middle element, we found it already. We will return the slow and it's done, right? But there is one thing to notice, guys, that it will not be, all these things, all this stuff, like we have set the previous next is null, it will not going to reflect right here, but we are assuming that it should reflect, right? So what we will do is we will pass the address, okay, right in this function, so that it should take an effect, okay. That means whenever we will return the middle element out of this given function, so it should also cause the fact that its previous is set to null, right? So that for any other function, it should not be a chaos. Are you getting me? So if you have any such doubt, guys, till this point or any such point before it, you can simply go ahead and ask me in the comment section about it. I'll be happy to answer all of your doubts. Okay, so I hope it should work now. As you have handled all such conditions, let's test it out. Okay, there is some runtime errors coming. Okay, I got the issue. So the issue is that we have not, considered any base condition right here where the function should stop, right? So basically the base condition is very simple, guys, that suppose there is only one element, right? Suppose, for 3, I'm calling its left, subtree to be filled with this particular sublist, okay, where the sublist actually contains only one element. So in this case, guys, what we have to do is the head is this, and the middle of this particular sublist is also this, right? So in this case, when we see that head is middle, so in this case we have to return back. We have to create, obviously we have to create the root out of this, out of this list, and we have to return back. So when we see that, we should not deep down, we should not go down and create the left and right for its, because the left and right will be nothing, it will be null, right? So in this case we have to handle it. So the condition will be when head is equal to I'm sorry, the middle, okay. So we have to return, okay, the root is required to home. So let us say that we have a node that is 3 at any point of time, and we have called a function that is get bst to fill its left subtree by this particular sublist, right? So this sublist is containing only 10, so it is required to minus 10 to be right here, right? So minus 10 should be returned. by this particular get PHT function, right? Where this particular sublist is passed. Okay, so I hope you got it. Okay, so as you have handled the base condition, now let's try it again. Okay, it accepted. Let's submit it. It should work now with no issue. Yeah, it worked. So I hope you enjoyed this particular video, and if you have enjoyed it, then make sure you subscribe to the channel, hit the like button, and comment how it helped you. And thank you for watching this particular video.